I will introduce binomial distribution, normal distribution today. I will not promise that we will cover it up, it will take some time. Okay, this is the most important distribution I would like to spend time on. Okay, this is also called as normal distribution or Gaussian distribution or bell shaped distribution. Okay. It is very important because it closely approximates many situations, real situations. It is perfectly symmetrical about its center point, which is the mean. Okay. So, it is a bell shaped, okay, and the truly interesting factor about this distribution not just lies in its bell shaped curve or its close approximation to reality. It is a very interesting distribution because the entire probability distribution function or the density function is characterized by only two quantities. So, if I know this two true quantities, I know the entire distribution, which is not in any of the distributions, You know the true distribution here the moment you know the two quantities, which is mean and variance. So, this is 1 by sigma square root of 2 pi into e to the power minus x minus mu the whole square by 2 sigma squared. Okay. And the interesting part is cannot be integrated mathematically to find CDF. CDF is nothing but capital F of x cumulative distributions, right. You cannot find cumulative distribution mathematically. Closed form solution does not exist because integral of e power minus x squared, that is not straightforward, that is not numerically, that is not analytically closed form solution does not exist. So, this is only solved numerically. So, solved numerically for to find probability of A less than x less than B. Okay. So, closed form solutions does not exist for this probability distribution function, and it is typically you have only two parameters which characterize the entire distribution, mean mu and variance sigma squared. Clear?
What is the significance of CDF?
The cumulative distribution function is what? It is summation of f of small f of x. Why is it significant? If I want to identify what is probability of A less than x less than B, what is it? That is nothing but capital F of B minus capital F of A. The cumulative probability up to the bth point minus cumulative probability up to the eighth point is nothing but probability. So, whenever you want to calculate probability, you only do CDF for a continuous case. For a discrete case, probability distribution function is one point, it is a point, right. For a continuous case, I told you probability of A less than x less than B. So, how do I compute this? I have to integrate this between A to B f of x dx. This is nothing but I can write it as 0 to or minus infinity to B f of x dx minus infinity to A f of x dx. This is nothing but f of B and this is nothing but f of A. So, you have f of B minus f of A. That is where CDF becomes important.
Closed form is not existing, is that a problem?
It is a problem, it is not neat, it is a problem. You cannot integrate it, so it is a problem. It is not a feature, it is actually a bug, but we can know how to come around this. I am giving it a priori so that we will define what is standard normal distribution and why we are doing it. Okay. So, now I have told you that we cannot obtain f of this one f of B minus f of A easily. Why? We have to solve it numerically, and whenever mu and sigma varies, every time you have to solve numerically. You see the problem? See, I cannot say I want to define a probability, understand the probability of an event occurring within a region, within an interval. let us say x lying between a to b. Okay. So what will happen if I have to do this, I have to do this integration whatever I have written, but this integration is not possible mathematically. So I have to numerically do this integration, but how many times will I do? Every time I have to go to do numerical integration. If I have analytical solution, I just need to plug in the numbers and then solution will come out. This is numerical integration. Every time I have to do numerical integration, and remember numerical integration is worst to do. In the last class, if you have taken last semester, you would know numerical integration is the last one. It is not as nice as differentiation. Numerical integration can run into overshoot, undershoot, overshoot problems. There is a lot of issues. So numerical integration is not a neat idea. You do not want to do it every time. So what did people think? That is where beauty comes in. It is characterized only by two parameters. What is it? Mean and variance or standard deviation. So instead of making every time solve it, you actually convert it into what is known as standard normal distribution. So what do? You remove the mean and divide it by variance, sigma standard deviation. So suppose x is with normally distributed, x is normally distributed with 0 comma sigma square, mu comma sigma square. What is z? After doing this transformation, what will happen? 0 comma 1. This is approximate. Understood? So I have removed the mean, so mean essentially becomes 0. I have divided by standard deviation, so the spread becomes 1. Variance becomes 1, the spread becomes 1, mean and variance becomes 1. So I have essentially converted any normal distribution to any variable with normal distribution to a standard normal just by using z equals to x minus mu. Why is it important? Now I can solve for only one solution, one equation, and I can do this numerically, say okay, numerically compute CDF for z from minus infinity to infinity. Notice this equation is a continuous curve valid for minus infinity to infinity. So I can compute the CDF for minus infinity to infinity for this only one equation, okay, and I can form a lookup table. So any normal distribution, any normal distributed variable you give me, what will I say? Change it to standard normal, go look at the lookup table, okay. You do not need to do numerical integration every time. That is the advantage. That is the advantage of doing this way. Make sense everyone? Why we are thinking about standard normal? Okay. So because you convert any normal distribution to a standard normal, go look at the lookup table. So the normal distribution is typically like this, all the way from minus infinity to plus infinity, and the standard normal center point is mu equals to 0, okay. The variance is what? Sigma equals to 1, okay. And what is the probability of x lying within 1 sigma? 34%, 34.313, okay. What is the probability of x lying within 2 sigma? Add this, 68.26. Now you can think of what is 3 sigma, add one more to it here, that is all, right. Now have you heard of all this 6 sigma companies etc., all qualities, 6 sigma, 3 sigma companies, 6 sigma, 3 sigma is age old. Now we talk about 6 sigma. What does 6 sigma mean? Okay, 99% of the area, that means a company making a, if it is a 3 sigma company, what is the probability that they will make an error? 0.3, 3 sigma, 3 sigma is 0.3%, 0.3 percentage. How about 6 sigma? I don't know, I think I have not even written the values, it is so high. It is somewhere 0.99, 0.00 some percentage. This is 99.7, it will go up to 99.99. So, it will be 0.1 percentage, 0.1 percentage. That means the absolute values it is 0.01 even, 001. Okay. So, the probability of TCS not delivering as per the expectation, since it is a 6 sigma company, is only 0.1 percentage. Does that mean that the company does not always meet the expectations? It is only true when n tends to keep always things with a pinch of salt. Okay. On an average, TCS will commit only 0.1 percentage error. That does not mean that this particular project will have 100% accuracy. Okay. You can only believe, or you can only take support that, oh, this company is good because they are 6 sigma, on an average they make only 0.1 percentage. Does not mean your project will be successful, simple, that is what it is. Okay. So, 6 sigma is always, all of them are defined over a larger n values, keep that in mind. Okay. So, this is how you start. So, now what is that you how do you get this? So, this is the standard normal table. Okay. Standard normal table where they have solved for minus infinity to infinity for standard normal, which is 0 comma 1. Okay. The infinity to this thing is so small that you will start from, and remember this is a bell shaped curve I showed you, this is minus infinity plus infinity, this is also symmetric. So, if I know the one side, I just need to multiply by 2 to get the other side. So, I just need to know from 0 to infinity, I do not need to know minus infinity to 0 because it is a mirror image. So, it is just enough if I know up to from CDF values for 0 to infinity, because the other one is just a mirror image of it. Okay. So, let us look at this table and then compute, let us say, I will ask you one question before we take a leave. Let us say I want probability of, find probability of 2x less than 4, x is normally distributed with 5 comma 2. Can you do this? Can you replicate this? What did I do? Probability of 2x lying between 2 to 4 given x is normally distributed with mean 5 and variance 2. What did I do? I first did z equals to x minus mu by sigma, standardized it, so that you have x minus 5 by 2 as the value. So, if x equals to 2, I know z equals to minus 1.5, and x equal to 4, z equals to minus 0.5. So, this is nothing but this one, this turned out to be probability of x z less than x less than, so probability of z less than, so this is nothing but probability of z less than minus 1.5, okay, minus probability of z less than minus 0.5, sorry, okay. So, this is what I have, okay, but probability of z less than minus 1.5 is what? Mirror image. So, that is nothing but probability of z greater than 0.5 minus probability of z greater than 1.5. This is the area. You understand the simple idea. So, z is nothing but x minus mu by sigma, I subtracted it, I got minus 1.5 and minus 0.5. So, that becomes 1.5 and 0.5, okay. So, 1.5 and z greater than 0.5 and z greater than, less than is symmetry, I use the symmetry idea, okay. So, typically I have z less than minus 1.5 and z less than minus 0.5, but what is z less than minus 1.5? Z greater than 1.5, and what is z less than minus 0.5 is z greater than 0.5, symmetry, that is the idea I have used, symmetry idea, right. So, this is what I have used, right. If you have 0.5, this is the region I am interested in, that is why I have a diagram, this is minus 0.5, this is minus 1.5. So Z less than minus 1.5 is what area? This region. Z greater than 1.5 is what? Okay, clear? And similarly Z less than minus 0.5 is this region, okay, and this region is Z greater than 0.5. So I have to subtract Z greater than 0.5, Z less than, probability of Z greater than 0.5 minus probability of Z greater than 1.5. What is probability of Z greater than 0.5? How do you find? This is a cumulative distribution table. This is a table, next time onwards you try bringing. So this is the cumulative distribution table. So go to, you have to find out the, this is a cumulative distribution table, CDF. This table is CDF table, okay. So 0.5, Z greater than 0.5 is what? Look at 0.5, what is the value? 0.500, this is 0.3085, and what is Z greater than 1.5? 1.5 up to CDF, you look at this 0.668, 0.0668. So then subtract both, you will get the area, right. So you see how to use the table, okay. This is a CDF table, clear, okay. With that note we will stop for today.